So hello again. We were cut off earlier in this class, and there was something that I wanted to show you in the last 10 minutes, which is directly related to the course and indirectly related also to Emacs and to operating systems. So I'm going to let you have a look at this screen. This is Emacs again, that I'm asking you to install. We'll talk about that in class. And you see two sides here on the left-hand side and the right-hand side. You see I can split the screen in two. And on one side, on the right-hand side, I have a so-called org file, which looks just like the file that I used to present the agenda to you. And on the other side, I have an aborted shell. So if I restart the shell, you see at the bottom that I'm using a command called plink, which in turn is part of a distribution called PuTTY, P-U-T-T-Y, in order to establish remote access. And what I'm establishing remote access to is this little Raspberry Pi that sits on one of my desktops. And it's a Linux box. I want to show you on the left-hand side is using SQLite in a Linux box. So I'm going to go down here. I'm going to tell the program where the shell is that I want to execute on the other computer, which is this network address using this account, the Pi. And when I do that, the connection is being opened. The password and identity has already been stored by Emacs. And now I'm working on the left-hand side on one computer and on the right-hand side on another computer. So let's go to the right-hand side. This, as I said, is a so-called org file in Emacs. And I have not hidden the meta information here at the top. I'm just going to explain this since you can look at it. This just means when this file is rendered in any format, in any form, do not provide a table of contents, toc nil. And when starting up, present all the different parts of the file, which are headlines with stuff below it, in an overview form, which is collapsed, which is what you see here, as opposed to this, which is uncollapsed. And the last one here is hide blocks, which means if there are any code blocks, I'm going to say what that is in a moment. If there are any code blocks, then please hide those too. So I'm going to just look at one of the code blocks here, SQLite. And as you can see, that did not work. This should have been shown like that. So this is a code block here, which is hidden. So on the left-hand side, I have a shell. This goes straight to the Raspberry Pi. On the right-hand side, I have a file with documentation and code and output, which is what I'm going to demonstrate in a moment. Let's first start the bare bones. Go back to the shell here on the left-hand side and start the bare bones program. And remember, in class I said this is a reason why we're using GNU Emacs instead of just the shell. The shell is the command line. I'm going to just show this here as well. This is the same shell if I type cmd search, the same shell that I get in Windows at the command prompt. So this is it's the same shell in the sense that it's a way of passing commands onto the operating system, but in the black window I can pass commands onto the Windows system. For example, look at the different files in on my box. And in the other situation over here, I'm looking at a Linux system. Command dir also works here, but there are a lot other useful commands. For example, ls for list, long list, and h, which means in human form. So here I get a list of my different folders here. Yeah. So let me actually go on the left-hand side to the home folder. And you see this completes. Now at the directory home pi on this little machine that I was talking about earlier. I can repeat the previous command. That's also nice. I can repeat commands here. And here you can see the different things that I have here. So this file, babel.org, Babel stands for the org mode package that allows me to do literate programming on the right-hand side. The same file I have here as well, but I'm looking at the file on the right-hand side on my Windows box. Let's just clear this up again and show you what I wanted to show you. So the command or the application that we are using is SQLite. It's actually called SQLite 3. I can look on this machine with the which command where it is. This is something you cannot do on Windows, and I can see the command exists, and I can just log into SQLite 3, and when I do that, I actually find myself on another shell. So this is the outer shell, and this here is the inner shell called SQLite. And I'm now inside the database management system. Now, if I go back on the right-hand side to the Babel file, there's a section here. I'm going to just make this the only section visible. There's a section here for SQLite, and this whole file just demonstrates the mixture of documentation code output. It says SQLite is a relational database management system. There's a code block here, which I can open like a headline, and it has various commands. Now, these commands are commands you're going to learn in the course of our course. And what I want to do is I want to use these commands on the left-hand side in the shell to show you what emerges, and then I'm going to execute them on the right-hand side, just to show you the difference between shell programming on the left-hand side and interactive programming on the right-hand side. That's the purpose here. Sorry to spend so much time talking about this. But actually, as I think I said, I've not taught literate programming before, and it seemed in this 5-language semester to be a good time to do that. So on the left-hand side, I'm going to look if there are any databases, the database command, and there are no databases, otherwise it would say the name of a database. I'm going to start with this command here, create table, which, as you can probably imagine, simply creates a table. So create table, Tabelle, that's the name of the table, and the table is supposed to have 2 columns. One column is called ID and is an integer. The other one is called name and is a text column. And then I close the command with a semicolon. Now you immediately notice the difference, I think, between the left and the right-hand side. There's no syntax highlighting here. I could actually add that if I wanted to, but I haven't bothered to do it. So I do this, and SQLite has no trouble with it. Now, I should have executed the command tables before. That's an SQLite command, and it says there is now a table called Tabelle. The table is empty, though. If I look at the table with the select command, select star, which means look at all the columns available using the select command from the table named Tabelle, semicolon to close the command, a bit like in C, actually. The answer is no. There's nothing there. So I need to put some data into that table. I'm going to do that with the insert command, insert into Tabelle, that's the name of my table, the following values. And if you were wondering, the commands that are purple here, create table, name, drop table, exists, those are highlighted because there are SQL keywords. They're both SQL and SQLite keywords. And in order to mimic that, if you like, I'm capitalizing, so I'm putting them in uppercase on the left-hand side as well. But I didn't have to do this. SQL actually doesn't distinguish, except in variable names, between keywords in larger and uppercase or in lowercase. So I'm going to put something in that table. And the values I put in is a number 1 for the first row, the first column, and my name, Marcus, for the second. Actually, let's call it Marcus. Let's see. Consistent to the example on the left-hand side. Again, semicolon to close the command. it accepts it, which is always a good sign. And if we repeat the select command from before, we see now there are two columns there, one and Marcus. I can actually make that a little nicer. As you can see on the right hand side, I can say, let's show me those data in column mode. And for the width, assume that the first column has a width of 3 characters and the second one a width of 10 characters, and give me a header row so I can see what's in the table, and switch that on. And if I now repeat my command again, then it looks like that. So that's pretty cool. And again, the left-hand side is executing this in a shell. You could work, in this shell, the Windows shell, just the same way. On Windows, where I've also installed SQLite, I can call SQLite. It looks the same thing. The difference you notice immediately is that the SQLite version up here on the left is 3.727.2 from 2019, while here I'm using a SQLite, recently installed SQLite version 2021. But otherwise, it's exactly the same deal. This SQLite has no tables and no databases, and I could use exactly the same sequence of commands to create it. Now, this is okay, but as I pointed out, if you have a result and you now want to put that result into another program, or you want to, plot the results of your column in some shape or form, you would have to swap between applications all the time. It wouldn't be obvious because the computer insists, I'm now looking at the shell. This is where my result is. I don't want this in another place. So it is very advantageous, very nice to actually have that all in one place. And this is what literate programming is. Brings us to the right-hand side, the other side of the screen, where we have this code chunk with exactly the same commands, but all in one go, all after one another. I could execute these commands, by the way, one by one. So I could, for example, open this in a buffer and execute them one row, one line by one. I'm not going to do that. I'm going to go back and simply execute the entire chunk with one command. Control-C, Control-C. You can see this at the bottom of the Emacs editor, and this is the result. So you see the result is exactly as on the left-hand side. The only difference is that it does give, because I printed the commands tables and database, it does say here which database I'm working with, which is some database file on my machine. I'm just actually going to show you which one that is. So just split the screen between upper and lower screen. And I'm going to go into this directory and show you, here's the Babel DB file, which is an empty database file that's at the moment being written. So actually I just wrote something into it, namely the contents of this new table. So I know this was a bit fast. I just wanted to demonstrate to you, again, the difference between doing interactive computing in the shell on the left-hand side and in org mode on the right-hand side. And I'm going to share this video with you and also with the other classes so you can have a nice experience. Thank you.